Hi, this is Dr. Paul Liu from University of Pittsburgh. Today I'm going to talk to you about my project proposal, printed metal films from particle-free inks for EMI shielding. This is a joint proposal with Satish Iyengar in statistics and Roger French at Case Western Reserve University. So this project seeks to combine fabrication of EMI shields, electromagnetic interference shields, the characterization of these shields, and machine learning techniques. We're seeking to characterize metal films fabricated by Fujifilm from electron inks, particle-free inks, and then use near-field EMI scanning to characterize these films and correlate this EMI scanning data with conductivity measurements, as well as optical topography characterization. We want to better understand how EMI shielding performance correlates to other characteristics that we can measure quickly. And we want to be able to speed up the cycles of learning and prediction of EMI shielding performance from EMI shields that have been fabricated by Fujifilm. So the standard that we're using is the ASTM D4935-18 standard. This is a method for measuring the electromagnetic shielding effectiveness of planar materials. It tends to be very time consuming and slow. And the idea is that we want to provide another way to assess EMI shielding performance by cross-correlating EMI shielding performance with conductivity properties and topography data. EMI shielding is very important. There are a lot of applications in military, aerospace, marine, and medical equipment. And for this specific project, we're focusing on mobile applications. So I do have a current project with electron inks, which is focused on creating transparent conductors. And this project builds upon that existing collaboration. So the first task in this project is going to be conducted by Fujifilm. It focuses on the fabrication of EMI shields, basically using inkjet printing to create thin films of metal. The metal films will be created using electron inks, particle-free based inks. So by using these particle-free based inks, you can achieve higher conductivity compared to particle-based inks, and therefore you can get better EMI performance. So here on the left, you see the ink that's been developed by Electron Inks when the company started up out of Illinois, UIUC. And on the right side, you see the characterization of one of Fujifilm's printed metal shields. So the chip size is about 1 inch by 1.5 inches, and each pixel is approximately 1 millimeter. So to get this EMI shielding performance data, it's a very time-consuming process of several hours, and we want to be able to accelerate this characterization method using other types of methods. So after Fujifilm has characterized their EMI shields, we want to characterize the surface topography. We can do this very quickly using surface profilometry, using white light interference data. We can very quickly get the topography of the printed film, like you see over here on the right. And we want to combine this with conductivity data. So the conductivity data may be done using 4-point probe, or we may use eddy current data to get the local conductivity. Then this data will be correlated with the EMI data that was obtained by Fujifilm. And based on building upon some previous machine learning algorithms that Roger French has developed for looking at electroluminescent data in solar modules that you see here on the right, we want to expand these algorithms so that we can predict and assess the EMI performance of printed metal films. Basically, we want to cross-correlate the EMI shielding performance data with the topography and conductivity data. So this project will deliver characterization data on Fujifilm's printed EMI shields. This will help them gain better understanding of their printed films and also help them improve their process flow. And we'll create new software, new machine learning algorithms that correlate this type of data, EMI shielding performance data, with other data that can be characterized much quicker. And this algorithms will be shared with the rest of the center.